Dear students, today in this session we are going to learn about the types of the beams and a little explanation about the some few types of the beams. In earlier session we are learned about the types of supports in which fixed support and roller support we have seen. With that we have covered all the four types of the supports, that is simple support, hinge support, fixed support, roller support. The hinge can also be placed in between the beams also, that we will see. So that according to the types of the supports, this is the simplification of the support nomenclature. The first one is roller support. Roller support has been shown like this. This is the roller support. This is the roller support. For this is the engineering marking for the support reaction. For the simple support also, this one is the nomenclature. And the same thing is gives you an upward vertical reaction. That's why they are grouped roller and simple support as one simple schematic diagram. And coming to the allowed movements, the simple support and roller support both are not allows vertical movement. They are not allowing vertical movement. Hence they are not allowing vertical movement, but they allows horizontal movement. That means this can move in horizontal direction and this can rotate in clockwise or anti-clockwise directions. So these two possibilities are there. They allows horizontal movement and rotational movement, but they are restricted towards vertical movement. So vertical movement is the only restriction we have, right? Whereas for the pinned or hinge support, one of the demerits of the roller or simple support has been removed. That is, the roller support has no restriction against horizontal support, horizontal movement. The same has been restrained in the hinged support. The hinged support has been shown like this, and this has the two types of restraints. One is vertical support and vertical direction and horizontal direction. It has the both. So hence the number of reactions available are two for this. You see for the roller or simple, the vertical reaction is only one. Here vertical and horizontal. So the number of reactions are vertical and horizontal. That is the two. Hence it has a restraint against vertical and horizontal. Only what is the possibility for the movement is which is not restrained, that is rotation. So rotation cannot be restrained, right? So hence this pinned or hinged support is used where vertical and horizontal restraint is required. Hence no movement in vertical and horizontal, but only we want to allow only rotation. Then we use the pinned or hinged joint. Hence the number of reaction is offered to by the pinned joint or hinged joint. That is, one is the vertical restraint and second one is horizontal restraint. So the support cannot be moved in vertical and horizontal direction, but it can rotate about the z axis. Remember, it can rotate about the z axis. See, The hinge support can also be introduced in between the members. In this figure, you see here a hinge member is introduced between the two members. This is the first member, here it is the first member, and this is the second member. In between the first and second, introduced a hinge. This is the hinge. So hinge can be introduced in between the members. In this figure, it is introduced for an axial member. That is, a load is acting at their axis of the member. So for this type also, the number of reactions are only two, right? And rotation is allowed at this point. At hinge point, rotation is allowed, but no horizontal, no vertical movement is allowed at the hinge point. Hence, restrained against the vertical and restrained against the horizontal. And you see the last one, here it is also a middle hinge. It is also an hinge is provided here, right? For this, the situation is changing. It allows the horizontal movement. Here, this hinge allows the horizontal movement, but it not allowing the rotation. So the hinge placement depending depends, and it also changes its reactions according to its placement. So, but anytime it gives only two reactions. But you please see here, when we provided a hinge in between the two axial members, it is not against for the rotation, it allows the free rotation. But we used the same hinge in between a beam members, at some distance at this from the top to bottom, we arranged like a couple arrangement. Then it have the resistance against the rotation. It has the resistance against the rotation, but its original of horizontal movement has been gone away, right? So it is not going to resistance against horizontal for this arrangement. So please understood that two variations of the hinge arrangement. One is for the axial member and another one for the beam member. So for this type of arrangement, you can vary the freedom of the supports, right, or restraint from the supports. That is the a good arrangement according to the your situations. But remember, every time it gives only two reactions. And last one, the fixed support. You see the fixed support provides fixed support provides total restraint in horizontal, vertical, and moment or rotation. You can say that is moment. So it can give total resistance. Hence, it is not allowed vertical movement, it is not allowed horizontal movement, it is not allowed rotation. Hence, the degree of reaction components are three. That's why here it is horizontal resistance, vertical resistance, and this one is moment resistance, right? So these type of arrangements are for the supports and their restraints. The fixed support is the best support for to build the rigid frames structures. But wherever the earthquake prone is there, there we have to require some flexibility in the structure. There we required some sort of supports different than the fixed support, or partial fixity is required for the earthquake structures. Today we are going to learn about the types of the beams and definition of the beam, and we will see the cases of the beams depending upon the support conditions. So actually the term beam is is one of the part of the structure. So we are in earlier session also we discussed in our building there are several components are there. Like a building is a complex structure, it has combined together. It is made a not a single piece. A building is not a single piece. It is made some additions of the elements. What are those elements? That is a foundation, then it is a column, then a beam, then slab, and in between we require some other elements also like flooring, right? So there are some other elements are also required, but structural elements are these four. One first one is foundation, second one is column, third one is beam, fourth one is slab. These are the structural elements. So if you observe, some of are in a horizontal position members, some are vertical position members. So the horizontal position members are slab. Slab is an horizontal structure, and beam is also horizontal structure, and column is a vertical structural element, and foundation is also vertical structural element. So these are the according to their positions, their axis is defined. So if you want to give some loads on those structural elements, we have to understood about their axis. So coming to the definition of the beam, we need to understand what is a structural element, right? So what is the structure? Structure is a combination of all the elements. So the complex structure is split into number of elements. A complex structure is split into number of elements. Each element is known a structural element. For example, complex structure is multi-story building, right? A multi-story building is a complex structure. So a building is obviously made of beams, columns, and foundation, RCC walls, and slab, right? It is made up of all those items, right? So it is made up of beam, column, slab, foundation, RCC, walls, if any, like that. These are a simple examples. But in general, other than these elements can also be placed according to the requirement of the design of the structure. So the structural elements are beams, column, slab, foundation, RCC walls. So a beam, as we earlier discussed about this, a beam is a horizontal member. A beam is a horizontal member, horizontal structural element. We can say it is a horizontal structural element that primarily resists loads. It will resist the loads according to the how the load should be applied. Loads applied laterally to the beam's axis. So laterally, the loads should be acted like a laterally. So you see, if I am taking a beam, if you say, if this is my beam, let us say that this is my beam axis. Generally, what would be the beam axis? If the beam thickness is like this, if the beam thickness is like this, so this one is beam axis. This one is beam axis. This one is beam axis. Let us say this is the axis, right? And what is the beam? Here it is the, and this one will be the beam. So beam enter, it is the beam. A beam have some axis which is might be at somewhere in between the beam element, right? So if the loads are, here it is saying that loads applied laterally to the beam's axis. So beam axis అనేది ఇది అవుతున్నప్పుడు మనకి బీమ్ యాక్సిస్ ఇది అవుతున్నప్పుడు ఈ బీమ్ యాక్సిస్కి లేటరల్గా అంటే పర్పెండిక్యులర్గా యూ కెన్ సే దాట్ యూ కెన్ అప్లై ది బీమ్ యాక్సిస్ perpendicularly. So beam axis ki perpendicular ga I just want to load. This is the loading situation. Axis ki perpendicular ga. So this is the perpendicularity. This is what he is telling that it should be laterally applied, right? So sometimes the loads can also be acts like this. How? This is the primary definition. What he want to say that this is the case. Actually it resists primarily in which direction it resists? Laterally. It resists laterally. So this is what he want to define a beam. A beam is a horizontal structural element primarily resist loads applied laterally to the beam's axis, right? But in some cases, what happens? Secondary. What is the secondary situation? He is saying that primarily it should be a lateral component. But sometimes the loads can also be like this. This is already we have seen that loads can be in inclined situation. Loads can also be happened as a inclined nature also. So then components will be resoluted and in terms of the cos and sin theta accordingly one is the lateral and one is it is very parallel to the its axis. One become lateral and second become parallel. You see that this one is a lateral force, lateral, lateral, right? Whereas the here it is a parallel force. You see this is a parallel parallel force. So this happens for the inclined structures. And before in the supports also, we are in the supports also we discussed there are different types of the supports in which one support can resist only vertical and another supports can also take the inclined loads, and some more supports are there which can also resist the moment. So accordingly we are classified those are simple support, hinge support and fixed beam, fixed supports, right? So the we are termed like this, right? So similarly a beam is a primarily resist load applied laterally to the they resist primarily laterally. So generally they are offering only this type, but some situations will come. In that situation they have to also secondary forces like parallel forces also should take by the beams, right? And its mode of deflection is primarily by bending. So before going to understood this one, we have to understood what is a deflection. We need to understood that what is the deflection, right? For this understood, you generally have walked on any bridge or any across the rivers or sometime you might be gone. If you see that if the our in that situation you are also noticed that if a structure is like this, if a structure is like this on which you are walking, let us assume you are walking on this structure. So while you are walking on this structure, what happens? This will give some bending. This will goes to like this curved shape. You can say that this will become a curved shape. So this obtaining under the loads, the deformation is known as deflection. So the deflection can be measured. The deflection can be measured. This axis to the deflected shape distance is known as the deflection. This distance is known as the deflection. is known as the deflection, right? And this shape is known as deformed shape. You please understood that this shape is known as deformed shape, right? So a deflection is will be a deformed shape, and it is the distance from the its original axis to the deformed shape, and hence the beam is primarily undergoes bending. So we are already seen that if a beam is like this, and in a it will deformed like a curved shape. So this type of is deformation is known as bending also. This type of deformation is known as bending, right? And the difference of this difference is known as deflection, and this one is known as deflection. And the shape is known as and the shape is known as if you see, this is the shape, and this shape is known as deflection deflection curve or deformation. So that is the terms we generally used in terms of a beam or any structural member. This will experience, right? You know, also when a athletic holds a stick to jump by using that stick. So while he is taking a jump, what happens to that stick? It will bends, right? So in every structure which is subjected to some loads, it is obviously it takes the deflected shape. That deflected shape is known as the bending. Similarly, the loads applied to the beam results in reaction forces at the beam's support points. Now you understood that a beam constitutes a supports. So it required some supports here. So at this point some support is there. At this point some support is there. So a beam required a support. So this is the span of the beam. This is known as span of the beam. అంటే బీమ్ యొక్క పొడవు, we can say beam యొక్క పొడవు, span of the beam. And what you can say that what is it is a supports. These are the supports, right? So these are the things, right? These are the supports. The total effect of all the forces acting on the beam is to produce shear forces and bending moments. You please understood that it should be the all the actor, it is of the shear force. It will undergo shear forces and bending moment. We will see about these in the upcoming sessions. Shear force is due to produced due to the parallel forces, unlike parallel force system. When a beam subjected to an unlike parallel force system, obviously shear force will produces. So please note that if a beam subjected to unlike parallel force system, then the beam subjected to shear forces. And when a beam is subjected to lateral forces, then the beam bends. Hence that bending moment will develop in that beam. So those induces the internal stresses. Due to that shear force and bending moment, internal stresses and strains will come. మనం కూడా అంటే ఎప్పుడన్నా మనం బాగా ఎక్కువగా వర్క్స్లో ఇన్వాల్వ్ అయి ఉన్నప్పుడు we feel some stress. So similar manner, when a beam is subjected to the loads, its internal components or material is subjected to stresses. So they are produces some force by area. Due to that load concentration, force by area will that area is under stress where the force is acts. The stresses is transformer to one end to the other end. Please understood that the stress is transformed to one end to another end. You see that if I am applying a load here, if I apply a load here, what happens to this point? Here the load, due to this load, stress will be developed here. This stress is also transfers to the downward layers. It transfers to the, this stress will reach up to this layer also, and similarly up to this, like in this curved path, because it is bending and it takes the curved deflections, so stress is also transformed into the all the layers. So hence stress will be transformed to the all the layers. And strain is nothing but change in the length also. Due to this is deformation, the beam is might not be the original dimensions also. So that strain will comes and deflections also will come. Obviously deflection is here. We are also noting that this is the deflection here for this layer. So these type of internal stresses and strains and deflections will introduce due to the action of the loads produces of shear forces and bending moments. Right? You will see that what is actually a beam as a figure. So first we will see the beam figure, then we come across all these things, right? So you see here, what is the beam here? You see here a beam is a horizontal member. Now you see this one is an horizontal member. See here it is a horizontal member is there, right? So this is known as the beam, right? You see, whereas this one is vertical member. So this is not the beam, this is a vertical member, right? So what is the beam? A beam is a horizontal member, right? So this is known as a beam, right? So it has the supports. You see, observe here, this beam is having the support. This is the support, and here also it has the support. A beam has the supports, right? It has one support here and it has another support here. Even you see in the figure also, for this there are two supports. Here it is a one support and here it is also another support. Now this portion is the beam, right? So similarly we can see here also at a number of places we can see that beam has the supports. You see here beam has the support here, a horizontal member, because this very in this figure, what is the horizontal member? This is the horizontal member, right? So for this, where is the support? This is the support, right? So this is completely a support. This is the support, a huge support is there, right? So for this beam, this is the beam, and if this is the beam and the support is here, this is the support, right? So that is the thing, a beam requires a supports at least at one end, right? So these are the, like for the beams they are giving supports here. You can see in this picture also we have the support. This is the beam, this completely a beam, right? This beam requires a support. This is the support and this one is also the support. So we are providing the supports for the beams. Here also see in this figure, this is the support and this is the beam, this is the beam, this is the beam. So these are the beams, right? So like this, right? Okay. Coming to the number of types of beams according to the which type of support the beam has. That means the horizontal member at their ends, which type of support it is. So that classification depends, and shape of the cross section. So we require which type of the cross section, what type of the cross section it is, and type of the support it is, and equilibrium conditions. We know the equilibrium conditions: sigma f of x equal to 0, sigma f of y equal to 0, sigma m equal to 0. Those equilibrium conditions you have to see that, and according to the length and their material, a beam are classified as per the support conditions. That means simply supported beam and simple supported both sides beams, simple supported at one end, and huge and hinge supported at other end beam. You understood that a simply supported beam according to the support conditions, a simple support at both the ends, right? And second one is we will see which type of figure it is, right? Now you are going to see the simple supported, right? Simple supported, how it will looks like. You see here a simple support. This is the simple support. See here, this is the simple support, a very normal support. There is no glue, it is there is nothing fasting and fittings are not there. So this is gives only vertical reaction, that what we see in the simple supported condition. So a beam having the span, and it has the supports at the both the ends. So that type of supports, if it is only simple support, that means if we represented only vertical reaction, then it might be a simple support or a roller support, right? So a simple support is just a simple arrangement without any connections, without any connections. So if it is your support, then the beam will be simply laid like this only. So there is no fixing between these two parts, just simply laying, right? Okay, so this type of support is known as simple support. And if the simple support at the both the ends, it is at the both the ends of a beam, then it is known as simply supported beam. Then you can say it is simply supported beam. So the simply supported beam, if it having at the both the ends only simple supports, then it can resist only vertical loads, hence unstable against horizontal forces. Hence it is unstable against horizontal forces. And simples supported at one end, you see that here at one end it is simple support, other end is hinge supported. At the other end is hinge supported, it is hinge supported. Here you see this figure, here it is a simple support, but here it is a hinge support. So simple support is on one side and another side is hinge support is there, then also it is a simply supported beam. But what is the advantage? It has the advantage to resist against both vertical loads and horizontal forces. It can resist the both vertical and horizontal forces. In the case of two simple supports at the ends, it resists only vertical loads, but it is unstable against horizontal forces. So that is the difference between the a simple support beam having at the both the ends supports, and a simple support beam having one side hinge support and one side simple support. That is the major difference between the simply support beams classification. Coming to the cantilever beam, a cantilever beam is one side it is a fixed support and another side it is a free end. Repeating, one side it is a fixed support and one side is a free end. What is meant by free end? That means there is no support at that end. If I mention, if in any manner, if we mentioned free end, means that end there is no support is is laid, right? And for the cantilever, at the one end it is a fixed end, that means rigid support, or it is a built-in support, or it has encrusted in the manufacturing time. So you can also see the cantilever beam here. So this is the cantilever beam. A beam rests on only one support, which is projected ends of a span. So a beam rests on only one support. You please understood that it has only one support, which is projected at ends of a span. సో ఒక ఒక సపోర్ట్ మాత్రమే ఉంది, ఎండ్స్ ఒక ఎండ్ ప్రొజెక్ట్ అయ్యి ఉంటుంది ఇన్సైడ్, రైట్? సో ఇది ఎక్కడ ప్రొజెక్ట్ అయ్యి ఉంటుంది? ఫిక్స్డ్ ఎండ్ దగ్గర ఈ యొక్క బీమ్ ఇన్సైడ్ ప్రొజెక్ట్ అయ్యి ఉంటుంది అన్నమాట, రైట్? అండ్ వేర్ దేర్ ఈస్ నో సపోర్ట్, దట్స్ ఎండ్ ఈజ్ నోన్ యాజ్ ఫ్రీ ఎండ్, right? The supported end is known as fixed end, and where there is no support, that it is known as free end. So with the advantage of the fixed end, we can have the resistance against both translatory forces and both translatory forces and రొటేషన్. సో రొటేషన్కి రెసిస్టెన్స్ దొరుకుతుంది మనకి, అలాగే ట్రాన్స్లేటరీ ఫోర్సెస్ కూడా రెసిస్టెన్స్ దొరుకుతుంది. బోత్ ట్రాన్స్లేటరీ ఫోర్సెస్, దట్ ఈస్ వర్టికల్ అండ్ హారిజాంటల్, ఈ రెండు ఫోర్సెస్కి ప్లస్ రొటేషన్, ఈ మూడింటిని కూడా మనం రెసిస్టెన్స్ చేయగలుగుతాము. సో ఇట్ కెన్ రెసిస్ట్ ది. సో దేర్ ఫార్ ఆర్ఎక్స్, ఆర్వి అండ్ ఎం, ఈ మూడు కూడా మనం రెసిస్ట్ చేయగలుగుతాము, రైట్? So this the support end which is built in fixed beam is called fixed end, and the other end which is no support is called free end. Right? Coming to the classification again, the third classification is fixed beam, in which both the ends are fixed in nature. There is no free end. The difference between the cantilever beam and fixed beam is, in the cantilever beam, one end is fixed and another end is free end. For the fixed beam, both the ends are fixed, only fixed supports. You see this figure? This. It has both ends are fixed supports only. Hence, it resists at both ends. So, you see in the figure, this end is also fixed end, this end is also a fixed end. You understood here? This also a fixed end, this also a fixed end. That means fixed support. Fixed end means fixed support. So for the sake of understood, you please see that here we have the three reactions we can find, and here also three reactions. Total 6 components we can have the resistance at both the ends. So that is the rigidity, more rigidity you can obtain in the fixed beam. That's why the many building structures are framed with the fixity, multi-frame structure you can say. Hence it can resist both the translatory forces, vertical loads and horizontal forces and rotation. The major difference between a cantilever beam and fixed beam is the cantilever beam having only one fixed end and other end is free end. That means cantilever beam contains one fixed support. The fixed beam contains two fixed supports. That means it has at both the ends it has the fixed supports. So coming to the further classification of that, continuous beam, overhang beam, single overhang beam, double overhang beam, truss beam. So we will see these classification in upcoming sessions. Moving to the next classification, based on constructional material, reinforced concrete. That means which type of material you are going to use. That is the classification. That is reinforced cement concrete, steel, timber, composite materials. So you see this in this figure, the reinforced concrete, this one is the RCC. We are using this one as RCC, reinforced cement concrete, in which steel and concrete of the cement concrete both we are using as a material. And steel, this is the steel, this is the steel. And timber beams are like this, we are using the timber material as a beam. And composite materials, you can use the combination of the steel and RCC, steel and any other member like this. It is a steel girder which is at the top, this is the steel girder, and below this is a another steel girder. Or it might be, if it is an RCC and it is a steel like that. So on the top you can assume that this is an RCC, and below it is a steel steel girder, right? So this type of a combination is known as the composite materials, right? And similarly, according to the based on cross section shapes, according to the based on cross section shapes, right? So cross section shape, you know that if you see your mobile making in front of you, it looks like a rectangle, it's not the cube now. That, so that shapes are known as the shapes. So that shape, which type of shape it is while cutting, it's along the length at the midpoint if you are cut, so which shape it is giving. So that is the shapes we are going to see, that one. So those are rectangular shapes, T sections, L sections, similarly. So these are the shapes will come hollow rectangle, right? These type of shapes. RCC also, it gives a different shape. Now you can identify which shape of this one. It is a rectangle, right? Similarly, we require some sort of this type of connections where the T sections will come and the L sections will also come. So how they looks like, the T sections will be looks like this. This is the continuity, and this would be the T section, right? This is the T section. In similar way, if the L section will also be possible at some situations. So this is the L section, right? So L sections, T sections is possible during the construction of RCC, and rectangular sections is quite common. This is the rectangular section. These are the quite common. For the steel beams also, where the steel is very costly, hence we are generally preferring for the hollow sections. You can see here it is an hollow rectangular section, right? Like a C section. So you can see this is the C shape. This is a C shape. You see this? This is a C section. And this also can be known as a C, right? You can see that these are C sections, right? And similarly, L section is this one. This is the L section. Similarly, I section, these are the I sections. So we have the I sections also here. We have the I sections. Similarly, we have the T sections. You can see here, it is the T section. If you observe this one, this is the T section. So we have these type of variety of sections we have. So H, L, W, C, tubes, rods, these type of sections are available for the steel beams. Based on cross section of the shapes also, we are already discussed about this one, how it will be looks like. Based on cross sectional, we are referred here. So the same thing has been again reaffirmed for your better understood, right? So these RCC sections have again shown for your better convenience and in the better understood we are seen here. So this one is a square section and rectangular section, circular section, right? L section, T section and plus sections. Like that you can manufacture according to your requirement. You can manufacture any shapes for the RCC structures, right? For the steel sections we are already understood that there are T sections are also be there. This one is the T section shape here, right? I section, these are I sections, L section, C section, hollow rectangular section, right? So we have that type of classification. Coming to the geometry, it has the curved beam, tapered beam and straight beam. First you understood what is a curved beam. You see generally beam is a straight in generally. In general how it should be, a beam should be a straight, right? If you see that a beam should be a straight in nature. But what happens now? The beam is not going to be a straight. It is in a curved nature like this. This is in curved nature. So you see here in the figure, it is a curved nature. It is a curved, right? So this curvature is known as the curved beam. If the beam is not straight and it having a curving, uh, curving towards the actual axis of the initial point, this is the initial point. So from this, it is not the straight. It is making some angle and it is also bending at each and every point. Then it is known as a curved beam, right? Tapered beam is that one, its length is going to be decreased. If you see that in generally what is a straight rectangular beam is like this. It is a, the depth is at this point is is similar to the end point also, right? The depth at this point is similar to end also. If I say it is a starting point and if I say this is an ending point of the beam, it is ending point. So it has one support here and it has another support here. So starting point to end point, the depth is same. If you see here, the depth is same, then it becomes a straight beam. But see this below figure, here you observe this one. Here the depth is this much, is very huge at the starting point. The beam starts here from this point. This is the supporting point structure, right? Here it will be extends towards the bottom also, right? So the beam depth is this much, very huge here at the starting point. Where you come to the end point, this is very less, very less. This is the end point. So the beam is tapered means its distance, its depth is going to be reduced. So initially this is the depth of the beam. If you see, this is initially this is the depth of the beam, right? So after some at a distance it is going to be reduced. So this is known as the tapered, this is known as the tapered beam. So this is known as tapered beam. So the depth is varying. Here it is the depth is 40. If you say if it is a 40 centimeters, whereas here it might be only 10 centimeters, right? So that is the variation along the its axis. If the depth is going to be reduced or increased, then it is known as tapered beam. See the beams are also be classified as per the method of construction. So there might be in situ or cast in situ. You see in this figure, the beam is constructed inside by using some formwork like that. After arrangement of the formwork, these structures, these are the stability structures to pour the concrete to make a beam there. So hence it is a in situ structure or cast in situ. We are making the beam inside site itself. ఏదైతే కన్స్ట్రక్షన్ సైట్ ఉందో మనం ఎక్కడైతే ఇల్లు కట్టాలో అక్కడికక్కడికే మనం అన్ని అరేంజ్మెంట్లు చేసుకొని అక్కడికే మెటీరియల్ తీసుకొచ్చి అక్కడే మనం ఎరక్షన్ అన్నీ చేసుకొని దానికి సంబంధించిన కాంక్రీట్ అక్కడే పోస్తాం. సో అటువంటి ప్రాసెస్ని మనం ఏమంటాం క్యాస్ట్ ఇన్ సిటు ఆర్ ఇన్ సిటు ప్రాసెస్, రైట్. అండ్ ప్రీకాస్ట్ మీన్స్ we made the concrete at a industry, not in the site, and we make those into some pieces of the lengths, and we have some fixing arrangement, and we will bring all those individual parts to the site. You see here, all are separated here, they are not combined here, they are separated here. So that means this piece is coming from the industry, this piece is coming from the industry. They are the pieces are manufactured at the industry, not in the at the site. And this slab is also manufactured in the industry, and they all together coming in a truck or lorry at the site, and after that they are fixing together at the site, right. This vertical structure is also manufactured as a precast, right. So these type of industrial manufactured beams are known as precast beams. And come to the pre-stressed, generally what happens is that we will pour the concrete after the reinforcement is placed, right. And we are not stressing more on the of the steel bars initially, but for the pre-stressed concrete, the steel bars we have to initially pressed before or after pouring of the concrete. We need to give some pre-stress, initial stress to the steel bars. You see here, there are number of steel bars are projected outside. But in general, in any concrete member, we will not see those type of projections. But for the pre-stressed concrete, we will notice the projection of steel bars outside because they are pre-stressed, right? So that it can take more loads based on equilibrium. So we understood that for which purpose we are going to design the beams, for the equilibrium purpose only. But sometimes what happens, we will go for more safety, then more, it is equilibrium, but it is having the more safety, right? So according to that, we have statically determinate beams. That means we can determine the reaction compounds. You see that it is a stable, the figure is stable, this beam is stable, this beam is stable, but it is internally stable. We are saying that internally stable. How it is internally stable? The number of reaction components for this hinge is 2. We require two reactions that we are seen in the table also, and for the roller support we have 1. So what it means? Total 3. What are the number of equations available for equilibrium conditions? 3. Therefore 3 is equal to 3, hence it is a stable. 3 unknowns, and you are going to solve the 3 with the help of the 3 equations. Therefore 3 unknowns can be solved by 3 equations, and it is a stable. Whereas the stable but internally unstable, you see that here it is, from the hinge we have the 2 components, 2 reactions we have, and for this one is one reaction vertical, and for the roller also another reaction, and for the hinge here also an hinge is there, hence 2. Therefore total 2 plus 2, 4, 5 plus 6, like that we have the 6 unknown reactions. How many equations we have? 3 basic equations: sigma f of x equal to 0, sigma f of y equal to 0, sigma m equal to 0. And in addition that there is a hinge is also addition is there, therefore we have the 4 equations are available, right. So therefore 4 equations are available. We have 6 unknowns, 6 reaction components are there, hence more reactions, more stability you are given, but finding of those unknowns is becoming clumsy, hence it is internally unstable, right? So that is the thing we have, right? Similarly, you can analyze this structure also, this structure also. These are all are internally unstable structures, right? Because they are having the more number of reactions when compared to the equilibrium equations required. So if the reaction components are more than the equilibrium equation, then the structure is stable, no problem. It is equal to or greater than the requirement. It is stable, but it has some extra rigidity that makes the structure some sort of internal instability. Okay? Based on situations and design, there are deep beams, effective span to there are deep beams. You see the beam depth. Please note this here. You see the distance between the two supports, right? And the depth of the beam. You see that here it is the depth of the beam. It is a huge. Now what is saying that effective span to depth. If the effective span is, what is the effective span? The center in generally, we are talking about in generally for a simply supported beam. This is known as center to center depth is center to center distance is known as the effective span. So if effective span L E effective span LE divided by depth, this is the depth, this is the total depth from this point to this end. So overall depth, I am talking about the overall depth. If I say overall depth, I need to have the and is equal to, or it should be less than. If it is less than 2 for a simply supported case, then it is known as the deep beams, right? So these occurs in the structures where are subjected to huge loads, like in metro or anything. You observe the depth of the beam is very much high, very much high, right? So these occasions will come according to the burdens or the load capacities to be resisted by the beams. And the girders are also the similar structures. They are arranged for the uh, big big loading members for the bridges. When you are going to construct for the bridges or for the framework of large buildings, we can use the girders as a combination of the steel beam or of any other materials to give the support to the large structures, right? For the like bridges. So you see here, this is the girder. Here to here, it is these are the girders. So this is the girder, right? There are the positions of the girders, right? So with this, the classification of the beams has been completed, and we are also seeing that which type of the beams like simple supported beam, cantilever beam, and fixed beam. We are seeing all these type of three types of the beams. Right? Thank you.